Okay, this is textbook problem number 30, which was our second example of a tangent substitution. It's got a little bit of a twist, so I wanted to video out the solution. So when you see that we have a 9, this is a 9 squared, right? A squared plus x squared. You should identify that you're going to use a tangent trig substitution, right, which is just a is 9, so dx is equal to 9 secant squared theta d theta. Let's pull the denominator off to the side and work on that. And we're squaring that. And that becomes an 81 plus, substituting for x, 9 tangent theta squared, and this entire thing is squared. And that's 81 plus 81 tangent squared theta squared. And continue to work on that. Factor out an 81. We get 1 plus tangent squared theta. And that entire thing is squared again. And we're left with the substitution of secant squared for 1 plus tangent squared theta. So this is 81 secant squared theta squared. And I'm going to rewrite this in terms of power of 9 just to carry them along. So we're going to make the substitutions and we're going to integrate. Make your substitutions and integrate. That's 9 secant squared theta over 9 to the 4th secant to the 4th theta d theta. Algebraically clean that up and you get d theta over 9 to the 3rd secant to the 3rd theta. One over, oops, I'm sorry, secant squared, reset, secant squared theta, right, cross that out and you're left with a square. Okay, so I'm going to substitute secant with cosine. Right, 1 over secant is just cosine. So I'm going to bring cosine squared theta up top over 9 cubed d theta. And then I'm going to use half angles on it. I pull out the 1 over 9 cubed. And I'm left with cosine squared theta d theta. Right? So the whole purpose of making that substitution, grabbing the pen, was to use half angles. So far we should be on pretty stable ground, what we've been doing. So this is going to translate into 1 over 9 cubed. I'm going to make the half angle substitution as 1 plus cosine 2 theta over 2. D theta. So carrying along here, I'm going to, pull out the 1/2. And I'm left with cosine of 2 theta d theta. It's best to have it in terms of theta for the reference triangle. So I'm going to make a hold on one second. Pause here. Okay, sorry about that. So we're going to integrate, which is where we just left off. Integrate, and I'm going to combine that now, and it's 1 over 1458. Integrating, the integral of 1 is theta plus sine of 2 theta over 2. Now, as far as the reference triangle goes, let's have another color. I won't know what to do with 2 theta. So here's the little bit of a twist. Everything was okay up until this point. We've seen it before. However, I'm going to have to use the double angle identity here, because I can't do anything with the reference triangle with regards to 2 theta. So I'm going to use the double angle identity, and that's what's new here. All right, we're going to use the double angle. I'm going to stay in the other one, rewrite this, so it's 1458, and I'm going to replace sine of 2 theta with the double angle identity, which is 2 sine of theta cosine of theta over 2. Okay, so those 2's are going to go, and we're left with 1 over 1458 theta plus sine of theta and cosine of theta. Now we can substitute everything that we need with the information from the reference triangle. So now we need to get it in terms of x. This should all be familiar using the reference triangle. Hopefully you're getting comfortable with this piece by now. That went pretty well. Okay. So x is equal to 9 tangent of theta. So tangent of theta is equal to x over 9. And recall that tangent of theta is just opposite over adjacent. So opposite of theta is going to be x. Adjacent to theta is going to be 9, which would make the hypotenuse equal to x squared plus 9 squared. And that's our reference triangle. Theta, if I solve for theta in this equation, theta is equal to x over 9, and oops, erase that. Solving for theta, it's tangent inverse of x over 9, right, because we have to find theta, and now we also need to find sine of theta and cosine of theta. So let's work on that. Sine of theta, opposite over hypotenuse. Opposite is x, hypotenuse is the square root of x squared plus 9 squared, and then cosine of theta is equal to 9 over the square root x squared plus 9 squared. Making the appropriate substitutions, we come down with, that's my therefore, right? 1 over 1458. Theta is tangent inverse of x over 9 plus sine, which is x over square root of x squared plus 9 squared, plus cosine, times cosine. Oh, jeez, I didn't realize it. Erase that again, grab the pencil. So this is x over square root of x squared plus 9 squared, that's sine cosine is 9 over square root of x squared plus 9 squared plus a constant. You could clean this up just a little bit. 1 over 1458. Tangent inverse, there's nothing you can do there. But here, you can combine those two terms. Multiplication of the square roots are going to cause the square root to go away. And you're left with 9x up top. So that's your final answer. So it's a tangent trig substitution with a little bit of a twist. And the twist was using the double angle identity.